Calculate the limit as x approaches 1 of stuff. Whenever you're trying to find the limit algebraically, you just take that number, substitute it in for every x, and hope that nothing crazy happens. Now, I'll tell you what I mean by something crazy happening. That's not going to happen here. Okay, we can plug in 1 for x squared, so this will look like negative 1 squared over 2 plus, plug it in again, 2 times 1 plus 4. And then use the order of operations to simplify stuff. So negative 1 squared is 1, so we get a half, plus 2 times 1 is 2, plus 4. Negative 1/2 plus 2 is negative, just kidding, 1.5 plus 4, which is 5.5. Now, this is just a normal number, which means this is my answer. Now, if I were to have something like infinity over infinity or 0 over 0, that would be a problem for a later day, which I know you will see if you continue to watch my videos. But all we have to do is take care of that. That's it. Compute the limit as x approaches 1 from the right side of this whole thing right here. Now, there is an algebraic method that you can do this. If I were to plug in 1, that would give me my answer as long as this whole thing isn't undefined when I plug in 1. Well, I'll tell you what right now. If I plug in 1, I get 0 on top. I get 1 minus 2 plus 1, which is 0 on the bottom. I can't plug in 1. This is undefined at 1. So what I need to do is I need to graph this. Now, I'm going to use a graphing calculator and paste the graph of the picture right here now. Now, as you can see from the picture, the limit at 1 actually doesn't exist because the left side and the right side don't meet up. But what this plus sign is saying is, where is my limit headed as it approaches 1 from the right side? As you can see from the picture, once I hit 1, it kind of dips down to negative infinity and keeps going to negative infinity, which would make my answer negative infinity. Now, if this was a minus sign, that would mean from the left, that would be positive infinity. And if I were to put just regular 1 here, since the left and the right side don't meet up, the limit does not exist. But in this case, I only care about where my number is going, where this graph is going as it approaches 1 from the right, and it dips down, which means negative infinity is going to be my answer. Calculate the limit as x approaches infinity of negative 3x squared over 4x plus 4. Normally, when I calculate the limit algebraically, all I have to do is just plug in whatever number that is to x and hope for the best. Well, I can't do that. Not here. Not here because I have an infinity, and if I plug infinity, I get infinity over infinity, and that doesn't make sense. You're not allowed to do that. So what you're going to do, this little trick, is find out what the highest degree variable is on the bottom here. It's x. Take that x, put it over 1, like this, yeah, and put it over 1 again for the numerator. I'm going to multiply the numerator and the denominator by 1 over the highest degree variable. Why does this do that? Well, there's a little trick that says if you have, some number over x and x is approaching infinity, x is going to get larger, 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 and eventually that'll turn into 0. Okay, so I can't have infinity over infinity, but I can have something different. So let's see what happens when I do that. I have the limit as x approaches infinity, right, of negative. I'm going to multiply 3x squared to 1 over x, which cancels out an x, so I get negative 3x over distributed property, 4x times 1 over x, the x's cancel out, giving me just 4, plus 4 times 1 over x, which is 4 over x. Now what I have is I can plug in infinity now. I have negative 3 times infinity over 4 plus 4 over infinity. 4 over infinity becomes 0. So this becomes negative infinity divided by 4, which is negative infinity. And so my answer, and if you wanted to double check this on a graphing calculator, you will see a type of line that kind of just dips down like that. This will head towards negative infinity. So when you get infinity over infinity, your decision is, well, which infinity is it going to? Where is it going first? Negative infinity is going to be my answer here. Tricky. Find the derivative using the limit definition. Oh, this one's going to be fun. The limit definition of the derivative is this. The limit as h, you might be thinking, what's h? You'll see. The limit as h approaches 0 of f of x plus h minus f of x all over h. This will give you the derivative. It's a mess, and there are shortcuts, but this is the problem that I created, so this is the problem that we're going to do. What I like to do is I like to take turns writing out what this is going to be, f of x plus h, and then kind of like plugging everything in, and magic will happen. But the first thing I need to do is find out what f of x plus h is. So to find f of x plus h, you need to rewrite this original equation. And remember, y and f of x, same exact thing. You're going to rewrite this equation, and you're going to replace every x value with x plus h. So f of x plus h is negative x plus h in parentheses squared plus 2 times x plus h in parentheses plus 1. So what I'm going to do is I'm going to write out that x plus h squared is a perfect square trinomial. I can FOIL this, split this and FOIL it, but I'm going to be a little lazy and just say that becomes x squared plus 2xh plus h squared. This is distributive property, so plus 2x plus 2h and then plus 1. Distribute this negative, negative x squared minus 2xh minus h squared plus 2x plus 2h plus 1. Now, you might be thinking, oh, please let one of these guys cancel out. It won't, but don't you worry. It will, something eventually will cancel out. Now, what I'm going to do is I'm going to, over here, rewrite this guy, right? I already know that f of x plus h is this. So I'm going to write out the limit as h approaches 0 of f of x plus h, which is blah, 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 blah. So negative x squared minus 2xh minus h squared plus 2x plus 2h plus 1. Now I'm going to subtract f of x. I know what f of x is. It's that guy. So remember, when you subtract, and I'm going to skip a step, when you subtract a polynomial, you are distributing a negative. So when I subtract this green parentheses, flip the sign. So you become plus x squared, that's good news, minus 2x, that's good news, and minus 1, that's good news. Now you might be thinking, why? Remember how I mentioned magic before? Well, things are going to disappear. First, I need to put this all over h. Negative x squared, and x squared cancel out. You should expect this to happen when you do problems like this. What else cancels out? 2x, negative 2x, positive 1, negative 1. So I now drop down the limit as h approaches 0 of negative 2xh minus h squared plus 2h. Now you might know from limits and computing limits algebraically that if I were to plug in 0 for h, and h, I would get 0 over 0, which is indeterminate, which is against the rules. But if I have an h in common with all of them, can I just factor out an h? I'll tell you, you can. So the limit as h approaches 0 of, let's pull out an h, negative 2x minus h plus 2 over h allows me to cancel out these h's. I missed. So the limit as h approaches 0 of negative 2x minus h plus 2 is going to turn that minus h into a 0, negative 2x minus 0 plus 2. And since I'm running out of room, I'm going to skip the minus 0 part and leave it at that. That is my answer. It's a mess. There are shortcuts for this, and I will have videos showing you the shortcuts, but this is using the derivative definition, the huge limit crazy thing right there. Always expect things to disappear. Always expect to factor out an h, and then your answer will be a whole lot friendlier once this whole mess is taken care of. Find the average rate of change over the given interval. So we have an equation, y equals x squared plus 2. We have an interval. I'm going to change that y into f of x just because it's the same thing, but I'm going to change it because I'm going to write out this formula right here. The average rate of change is the same thing as f of b minus f of a over b minus a if b and a are the endpoints of your interval. And you might look at that and say, well, that's a lot like slope. Yeah. Yes, it is, because rate of change is slope. So what I have to do before I even start this is I need to find out what f of b, or f of negative 3/2 is, and what f of a is. So f of b is going to be f of negative 3 over 2. And that's going to become negative 3 over 2 squared plus 2. Negative 3 over 2 times itself is 9 over 4 plus 2, which is, what is 9 over 4? 2 1/4. So 2 1/4 plus 2 is 4 1/4. 4.25. All right, so that's f of b. Let's get a different color and do f of a, which is negative 2. So f of negative 2 is equal to negative 2 squared plus 2. Negative 2 times itself is positive 4. Positive 4 plus 2. This math is a little bit easier, 6. So now that I know that information, f of b is f of negative 3 over 2. And f of negative 3 over 2 is 4.5. So f of b is 4.5. 4.25, apologies. Minus f of a is negative 2. F of negative 2 is 6. So 4.25 minus 6, all these colors, over b minus a is going to be negative 3 over 2 minus 2. So I'll just write that down in black. Negative 3 over 2 minus negative 2. 4.25 minus 6 is negative 1.75 over Negative 3 over 2, double negative. So negative 3 over 2 plus 2 is 0.5. And that's positive. And negative 1.75 over 0.5 is negative 3.5, I think. Yeah. Negative. We got a negative 1. So negative rate of change is decreasing. Which makes sense because that's a parabola going down in this area. So I like it. I like it a lot. Fun. Find the value of a that makes the function continuous everywhere. So we have ourselves a piecewise function. That's a mess, but it's over t squared. It tells you that t can't be 0. Well, it makes sense because if you were to throw in 0 for this guy, you would get 0 squared on the bottom, which is 0, which means you get an undefined function, which is impossible. So what's going to happen is you're going to get a graph of this, and you're going to have a hole or an asymptote of some kind or a breakage at 0. But I need to fill that 0 in. Now, I'm like, okay, well then find where things fall apart. Well, I can't just plug in 0 because it won't work. So what I need to do is I need to run to Desmos and make a graph. So I'm going to go to Desmos and do a graphing calculator. You could also do a regular graphing calculator, run to your own graphing calculator, but I'm going to graph this guy right here and see where my equation exists at 0. And then I'm going to paste that graph right there. All right, so if you take a look at my graph, and I zoomed in quite a bit, I typed this exact same thing into Desmos on my phone. I had to use X's instead of T's because that's all it gave me for the phone edition of Desmos. If I were to try to take my thumb, or if you're on a computer, take your mouse and hover over where X or T is 0, it'll say undefined. But if I get awfully close to 0, it'll tell me that T, or the Y value, is 0.25. So in order to fill that hole in, A has to be 0.25. Right now, I see this weird image that looks like that, but there's a hole there at 0.25. By allowing A to be 0.25, it fills that hole in. Now it's continuous everywhere. That's my answer. Find the derivative of y equals 5/4 x to the 2/3. If you're just finding the derivative of a polynomial and you have a bunch of, exponents, variables, coefficients here and there, that requires only the power rule. Now, this is what the power rule says. I'll just quick write out the definition. d dx means you take the derivative of, some constant, I'll call a, x to the n power. This is what I have here. A would be 5/4, x is x, n is that exponent right there. What you do is you take that n, you drop it down, you multiply it to the coefficient, keep x, and subtract 1 from n. That is the power rule. Again, bring the exponent down, multiply it to that, subtract 1 from there. So let's get rid of this. Okay, let's get rid of this now that I know that. What I'm going to do is y prime, or I could call it dy dx if I wanted to. I'm going to take that 2/3, I'm going to bring it down, multiply it to the 5/4 that's already there. X is x, and 2/3 I'm going to subtract 1 from. All right, so a lot of cleanup on this problem, but, that's fine. It's part of the job. 2 times 5 is 10. 3 times 4 is 12. I can simplify that. X to the 2/3 minus 1. That's the same thing as saying 2/3 minus 3/3 for those of you who hate fractions. All right, so let me clean all this stuff up a little bit. That gives me 10 over 12 is 5 over 6. X is X. 2/3 minus 3/3 is negative 1/3. So the way I will wrap this problem up, and I'll actually take 2 steps to wrap it up, is a negative exponent drops x to the other side of a fraction bar. Right now, it's on the invisible top of a fraction bar, even though, there's no fraction bar. I could put over 1 if I wanted to. Now I have it on the bottom. So 5 remains in the numerator, 6 in the denominator, x to the drop it down and make it positive 1/3. Now, you can leave it like that if you want to, but an exponent of 1/3 also gives you the cubed root, so this is the other way that we could write this out. Either of these is perfectly fine, either of these is simplified, and that's my guy. Y equals negative x squared. Find, this means the second derivative. So I'm going to take the derivative once. I'm going to take the derivative a second time and see what I get. So the first derivative, d regular y, d regular x, forces me to use the power rule. So the power rule is you take the exponent, you drop it in front of the x, or multiply it to whatever coefficient is there. My coefficient's -1, invisible 1, but -1. So I'll keep the negative there, drop the 2 down, the 2 in front, keep x the way it is, and subtract 1 from the exponent. So 2 minus 1 is 1. That's sloppy, so -2x. Now I have to take the second derivative, which means I take the derivative of that guy right there. So the way you write out the second derivative is d squared y dx squared. You could put, that would also mean second derivative, y double prime, but, whatever. Whenever I'm taking the derivative of a coefficient, forgot my word there, times x, just an x to the invisible 1, you just have the constant now. So if you're wondering, well, why? Well, pretend that's an invisible 1, multiply the 1 out in front, nothing changes, subtract 1 from 1, so x to the 0 is nothing, the x goes away. This is my answer right here. So the second derivative of negative, that's the worst looking circle I've ever made in my entire life. The second derivative of negative x squared is -2. That's it. All right, y equals -2x cubed minus 4x to the negative third. And my job is to find, oh my goodness, the third derivative. Whew. All right, I can do this. Dy dx means the first derivative. And I'm going to use the power rule not once but twice. The power rule means I take my exponent, multiply it to whatever coefficient I have here, and subtract 1 from the exponent. So take the 3, multiply it to -2, -6. Take 3 and subtract 1, and x to the third becomes x squared. But I got to do it again. -3 times -4 is +12. Interesting. X to the -3 minus 1 is -4. That's my first derivative. Now I have to take the derivative of that guy. So that's d squared y dx squared. I can write that out as y double prime if I want to, but, I already wrote it out as that. Power rule again. Take 2, multiply it to -6 to gives me -12. Take x, leave it that way. 2 minus 1 is invisible 1, so I won't write 1 there. I know better. -4, multiply that to +12 to give you -48. X to the -4 minus 1 is -5. So that's my second derivative. I had to find the third derivative. Y triple prime. So -12 times x Okay, drop down. Oh, there is no, well, technically there's an invisible exponent, so multiply negative 12 times 1, you get negative 12. 1, invisible 1 minus 1 is x to the 0th, which means x goes away. So remember, if you're taking the derivative of blah, 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 x, the x just goes away and you're left with blah, blah, blah. Okay? Okay. Negative 5 brought down and multiplied to negative 48 is going to be positive 240, I think. I'm pretty sure that looks about right to me. X to the negative 5th. Subtract 1 from negative 5. That gives you negative 6. And let me clean this up a bit and say negative 12 plus. Whenever you have a negative exponent, move it to the other side of a fraction bar. You might be thinking, what fraction bar? Well, technically there's an over 1 here. So leave 240 on top, the numerator. Drop down x to the 6th on the bottom. That is your third derivative. The end, the answer, bada bing. Find the fourth derivative of y equals negative 5x to the 4th. All right. Well, this is going to use the power rule. Okay. Whenever you have, coefficient, exponent, variable, power rule. Okay. Don't overthink it. The first derivative, dy dx, is going to be take that 4, multiply it to negative 5, so negative 20, and subtract 1 from that 4, x to the 3rd. That's the power rule. Take your exponent, multiply it to your coefficient if you have one, otherwise bring it out front, and then 4 minus 1, exponent minus 1, there you have it. That's the first derivative. I have to go all the way to the fourth derivative. So d squared y dx squared is going to have me taking the derivative of that guy. Take 3, multiply it to negative 20, gives me negative 60. X to the 3 minus 1 is 2. That's my second derivative. Okay. In real life terms, that's acceleration. But you didn't ask. I just told you anyway. D cubed y, that's supposed to be a 3. It looks awful. Dx cubed is the third derivative. Take 2, multiply it to negative 60, so that's negative 120. X to the second minus 1 is going to be x to the invisible first. I'll leave it like that. That's called the jerk. You're a jerk. It's a dance. Look it up. It's great. Now I have to take my fourth and final derivative for this problem. So d to the 4th, y over d x to the 4th. Whenever I'm taking the derivative of something x, the x goes away. Why? Because that's an invisible 1. So if you take the 1 out front, it doesn't change to the negative 120 in any way. 1 minus 1 is 0, so x to the 0 is no more x. So there you have it. Fourth derivative. Find the derivative of y equals polynomial times another polynomial. Now there's two ways that I can do this. I can foil, well, not really foil, but foil this whole thing out, do power rule a bunch of times after I simplify everything. That wouldn't be the worst thing ever. But whenever you have something times something, a function times a function, you could use what's called the product rule. Now, the product rule is this. You call one of your functions u, and you call another one of your functions v, and the derivative of u times v is going to be u prime v, so the derivative of the first function times the regular second function, plus v prime u. In other words, the derivative of the second function times the first function. Okay? So what I need to do is I already know what u is. I already know what v is. I'm going to go over here and I'm going to try to find out what u prime is and what v prime is. So u prime is going to be the derivative of this guy here. All right, I have a sum of powers, so I'm going to use the power rule once, twice, and 3 times for u prime. The power rule says that if you have a coefficient variable exponent, you take the exponent, multiply it to your coefficient, and subtract 1 from your exponent. In other words, 4 times -2 is -8. X is x. Subtract 1 from 4 and you get 3. So let's do it again. Bring down the 2. 2 times 5 is 10. X is x. Subtract 1 from 2 and you get invisible 1. The derivative of a number, just a constant, is always 0. So that's that. The derivative of 4 is nothing. I'm not going to write out any more. So that's u prime. Now I need to find out what v prime is. V prime, again, is going to have me use the power rule 2 times. You take the number that's the exponent, multiply it to your coefficient, so 2 times -3 is -6. X is x. Subtract 1 from 2, so invisible 1. And then we have 2 here, which when I take the derivative of a constant is just like that guy, goes away. So now what I have is I have my u prime, there you are. I have my v, there you are. Plus I have my v prime, there you are. And I have my u, there you are. So y prime is going to equal u prime, which I made green. Let me get my colors back. I'll put it in parentheses. U prime is -8x cubed plus 10x times v, which is -3x squared plus 2 plus v prime, which I got to be -3x, so let me get my red. Or I'm sorry, -6x, so -6x, not 3x, times u, which is -2x to the 4th plus 5x squared plus 4. Now, if you're taking this for a college class, maybe you have a professor that's like, that's good enough for me, but no, I don't like it. It's too sloppy for good old Mr. Perich. So what I'm going to do is I'm going to FOIL this guy out. I'm going to distribute that guy out, super combine like terms, get an answer, hopefully have enough space to do all that. -8x cubed times -3x squared is going to be +24x to the 5th. Okay, that's the F in FOIL. -8x cubed plus 2 is going to be -16x cubed. That's the O in FOIL. 10x, a very sugary term. 10x sugar. Look it up. 10x times -3x squared is going to be -30x cubed. Ooh, simplifying right there. Probably not the only thing, though, so I'm going to wait. And 10x times 2 is going to be 20x. This guy's just regular distributive property. Boom, boom, boom. Got to get that boom, boom, boom. Black Eyed Peas. Just hitting all the puns today. -6x and times -2x to the 4th is going to be 12x positive to the 5th. So that will combine with that when I get there. -6x times +5x squared is going to be -30x cubed. So another cube to combine with the other cubes that I got over there. And -6x, I already did the line, but I did it twice. -6x times 4 is going to be -24x. All right. Let's bring out a few more colors. Do I have anything with x to the 5th? Yes, I do. I have 24x to the 5th plus 12x to the 5th is going to be 36x to the 5th. There you go. Is there anything like -6x to the 3rd? Yep, -30x to the 3rd, which is -46x to the 3rd, minus another 36 or 30x to the 3rd. Any more x to the 3rds? Nope. So -16 minus 30 is -46. Minus 30 again is going to be -76. 10, 9, 8, 76 x cubed. That's a Philadelphia 76ers reference. Look that up. Again, punning very hard today. 20x, -4, or 24x is -4x. And there you have it. That's my y prime. Power rule. And again, what I could have done is I could have superfoiled that whole thing out, done power rule a bunch of times, but I didn't. Use product rule. And product rule is going to be very important. You're going to see that a lot, especially when you deal with trigonometric things. I'll have videos on that eventually. Find the derivative of y equals a polynomial divided by a polynomial. Well, if you have a polynomial divided by a polynomial, the best thing to do is use good old quotient rule. What's quotient rule? Well, you label the numerator u, you label the denominator v, and do u prime v minus v prime u over v squared. So we know what u is. We know what v is. We are going to find u prime and v squared. So u prime is going to be the derivative of this numerator. So the derivative of 4x to the third, power rule, multiply 3 times 4 is 12, subtract 1 from the exponent, x squared, minus multiply 2 to 3, which is 6. Turn that 2 into a 1 after you subtract 1, and that's u prime. V prime is going to be the derivative of the denominator. 4 times 5 is 20, so we got 20, subtract 1 from 5, that gives you 4. Minus 4's derivative becomes nothing, so that's nice. I also have to find v squared. Now, v squared is going to take this entire denominator and square it, which means it's not going to be this times this minus that times that. If you square it, you have to do perfect square trinomials. So that actually simplifies out to 4x to the 5th times itself, so 16x to the 10th. Multiply these two together and multiply it by 2. So 4x to the 5th times negative 4 is negative 16x to the 5th times 2 is negative 32x to the 5th. And then square that and you get 16. So let's find the derivative. Let's put it all together. Y prime. Y prime is going to equal u prime, which I said was 12x squared minus 6x times v, which is green, 4x to the 5th minus 4 minus v prime, which I made purple, so 20x to the 4th times u, which is red, so many colors, 4x cubed minus 3x squared, that's that. It's all going to be over 16x to the 10th minus 32x to the 5th plus 16. So let me FOIL this out and then distribute that and see if any magic happens, see if anything disappears. It's possible. I don't know. Maybe I could do some factoring. Maybe, maybe not. We'll see. 12x squared times 4x to the 5th is going to be 48x to the 7th. 12x squared times negative 4 is negative 48x squared. Negative 6x times positive 4x to the 5th is negative 32x to the 6th. Negative times a negative is a positive 24x. This distributes, so negative 20x to the 4th is going to give you negative 80x to the 7th when you multiply it by 4x cubed. And negative 20x to the 4th times negative 3x squared is going to be positive 60x to the 6th. All of that, all of it, still over 16x to the 10th minus 32x to the 5th plus 16. All right, so let's see if we can do some combining, and I'll bring it over here just in case there's more factoring going on. I'm not sure what my answer is going to be. I'll go standard form, biggest degree first, 48 x to the 7th minus 80. X to the 7th is going to be negative 32. X to the 7th. Let's get a different color out here. Negative 32 x to the 6th plus 60 x to the 6th is 28 x to the 6th. I had to think about that for a second there. That's supposed to be x to the 6th. What else? Nothing else combines. So negative 48x squared plus 24x. All right. I think I'm good. 16x to the 10th. Oh my gosh. 16x to the 10th minus 32 x to the 5th plus 16. The only thing that I can do, and I'm running out of space here, so I'm going to do this all in my head. I can factor out a 4 up top. I can factor out an x up top. But if I factor out an x up top, that does mean nothing for the bottom. But if I factor a 4 out on top and factor a 4 out on the bottom, all the 4s disappear. So what I'm going to do is I'm going to literally divide each and every one of these guys by 4. That'll get me my final answer. So negative 8 x to the 7th plus 7 x to the ugly looking 6 that was minus 12 x squared plus 6x all over 4 x to the 10th minus 8 x to the 5th plus 4. Never said it would be pretty. I just said it would be fun. And that's quotient rule for you. Compute the derivative of stuff involving trig functions divided by stuff involving more trig functions. This is going to use the quotient rule. So I'll call you U and I'll call you V. And the quotient rule says, if I need to find the derivative of a quotient, do U prime V minus V prime U over V squared. So I have to find U prime V. So U prime first is going to be the derivative of that. The derivative of a sine is cosine. So cos x plus 1. On the bottom, I'm going to take the derivative of, I already used green, can't use it twice. Purple. V prime is going to be nothing plus the derivative of cosine x, which is negative sine x. V squared is going to involve me taking that guy and squaring it, which I'm going to write out as that and leave it that way because I have a feeling nothing special is going to happen if I were to FOIL it out. I would get 4 plus 4 cos x plus cos squared x. Nothing special is going to happen, I don't think. Not off the top of my head. Maybe I'm wrong, and we'll figure it out. All right, let's put this all together. So I have U prime, which is blue, cos x plus 1, that's U prime, times V, which is green, so 2 plus cos x minus V prime, so minus negative sine x is going to be plus sine x. See what I did there? Minus negative sine x is plus sine x. And then regular u, which I made red, that's going to be sine x plus x. All of that is going to be over 2 plus cos x squared. Let's do some foiling, see what happens. 2 cos x plus cos squared x plus 2 plus cos x plus sine squared x plus x sine x. Ugh, looks sloppy, but I fit it in. Fun fact, cos squared x plus sine squared x is 1. So after I put all of that over 2 plus cos x squared, I can say 2 cos x plus cos x, which is actually 3 cos x, plus cos x squared plus sine x squared, which is 1. So you guys cross out to become 1. 1 plus 2 is 3. Plus x sine x over 2 plus cos x, all of which is squared. And if I FOIL that out, I don't think anything special is going to happen. I think that's my answer. So yeah, quotient rule with trig functions. Very interesting. Find the derivative of f of x equals the fourth root of negative 3x to the fourth minus 2. So what we have here is we have a function within a function. So that's going to require the chain rule. Now, a lot of teachers might use like u's and v's and f's and g's, but I don't like to do that. This is how I like to view the chain rule for me. This is how it works in my little brain. I have an outside stuff and I have an inside stuff. What you're going to do is you're going to take the derivative of the outside stuff, okay, keep the inside, and multiply everything by the derivative of the inside stuff. Okay, so take the derivative. So first off, before I can even think about doing this, I need to rewrite it. F of x equals, instead of the fourth power, or the fourth root rather, I'm going to turn that into the 1/4. So there's my outside stuff. Okay, my inside stuff is negative 3x to the fourth minus 2. Okay, so the derivative, let me get some different colors going on here. The derivative using the chain rule is take the derivative of the outside stuff. So that 1/4 is going to come down. So you're pretending that this is like the to the 1/4 power. Bring down the 1/4, all right? Subtract 1 from that 1/4 gets you negative 3/4. And that's the derivative of the outside stuff. Keep the inside stuff. So negative 3x to the fourth minus 2 is going to stay there. But we're going to multiply everything by the derivative of the inside stuff. So the derivative of the inside stuff is going to be multiplying this to negative, or the derivative of negative 3x to the fourth, which is negative 12x to the third, minus 0. So let's clean this up. Let's clean it up. I have a fraction, okay? That's going to go to the bottom of a fraction, so let me write a big fraction. I have right now 1 on the top part of the fraction, the numerator. I'm not going to do anything yet. 4 appears to be on the bottom. Everything taken to a negative exponent is going to have me drop that down and make it 3x to the fourth minus 2, negative 3x to the fourth minus 2 to the positive exponent. Then this is technically over 1, so I'm going to write negative 12x to the third. And my last step is going to involve me cleaning this up. So I'm going to divide 12 from 4, bring the negative out front. So this becomes 3 over, and I'm going to put this back in root form because that's how it was given to me. So I'm going to say the fourth root of negative 3x to the fourth minus 2 cubed. Now, there's multiple ways that all of this could be written out. Multiple ways, but this is the way that I ended up with. So this is the way that I'm sticking with. The end. Just kidding, not the end. I forgot x to the third. Hee hee. The end. Find the derivative f of x equals sine 2x to the third. All right, so I have a trigonometric function, but instead of just having sine x, I have other stuff. So this is going to require the chain rule. All right, remember when you do the chain rule, there's 3 steps. You're going to take the derivative of the outside stuff. Okay, so outside stuff derivative, keep the inside stuff, but then multiply everything by the derivative of the inside stuff. So you might be looking at this and saying, all right, well, what's outside, what's inside? Well, that's inside, and the sign is outside. So the derivative of this using the chain rule is going to be the derivative of sine, which is going to be regular cosine. Keep the inside stuff, but multiply everything by the derivative of the inside stuff. So, which I should have put there. So that would be 2 times 3 is 6. X to the third becomes x squared. And just to clean it up a little bit, I'll bring it out front. 6x squared times cos 2x cubed. And that's my guy. That's my answer. Find the derivative of a polynomial times a trig function with an x squared in it. All right. So this is going to involve a combination of product rule. And then when I take the derivative of this guy, I'm going to use chain rule. So remember, product rule is u prime v plus v prime u. So let's set that all up. So this is regular u, this is regular v. I already said that. So it's right there. U prime is going to be drop down to 5, 10 x to the fourth plus nothing. V prime is going to involve chain rule. The chain rule is take the derivative of the outside stuff, keep the inside stuff, but then multiply everything by the derivative of the inside stuff. So v prime is going to be the derivative of the outside, so the derivative of cosine, which is negative sine. Keep the inside, x squared, but multiply everything by the derivative of the inside. And the derivative of x squared is 2x. So cleaning this up, I get negative 2x sine x squared. So let's put this all together. Y prime is u prime, which I called 10x to the fourth, v, which is cos x squared, plus v prime, which was negative, so let's put that plus into a negative, minus 2x sine x squared times u, which was 2x to the fifth plus 3. I know I could distribute that, make that negative 4x to the sixth, negative 6x, and then, attach sine to it. But that really won't get me anywhere. Nothing's going to cancel out if I do that. I don't think it will. Nope. So I'm going to leave it like that. It looks kind of sloppy, but it's acceptable. So that's that. That's power rule or product rule and power rule and chain rule. So many rules. Where are we? School? Just kidding. Thanks for watching. Like and subscribe. Find the derivative of a polynomial divided by a trig function where the inside of the trig function is more than just x. So what we're going to have is we're going to have quotient rule. So I'll call u u. I'll call u v. And quotient rule is as follows. U prime v minus v prime u over v squared. So I have u, I have v, I have to find u prime, I have to find v prime, and I have to find v squared. So u prime, let's make that, I don't know, green. I haven't used green yet. U prime is going to be just, straight up power rule. Take that 2, multiply it to negative 2. That gives me 4. Drop that x squared down to an x to the first. Minus 5 disappears when you take the derivative because it's a constant. Dunzo. Now, to find v prime, that involves me using chain rule. So chain rule is going to be the derivative of the outside, keep the inside, which I'm putting in parentheses, so this is the inside, but then multiply the whole thing by the derivative of the inside. So the derivative of the outside is going to be the derivative of cosine negative sine. Again, chain rule is the derivative of the outside, keep the inside, that's supposed to be a 2, keep the inside, but multiply everything by the derivative of the inside. So I'm going to multiply everything by, drop that 3 down, multiply it to 2, so 6. X to the third becomes x squared. So let's make that a little bit more presentable and throw that negative out front, the 6x squared out front as well, and then sine of 2x to the third. Now v squared, and I'll make that blue, I haven't used blue yet, except for over there. V squared is just, don't overthink it. When you have a cosine and you square it, you only square the cosine part. So v squared is going to be cosine squared of 2x to the third. That's it. Okay, so let's put it all together. Okay, u prime, which was green, u prime is going to be negative 4x times v, which was the original cos 2x to the third. So I'm writing that out carefully. Minus v prime, which was negative 6x squared sine 2x to the third. So double negative is going to make minus negative. So minus negative is plus 6x squared sine 2x to the third times u, which is this little polynomial right there. So I'll put that in parentheses. I'll actually put a nice little bracket. Negative 2x squared minus 5. Close that up. All over cos squared 2x cubed. Now, I'm going to stop there because I guess what I could do is if I really wanted to go above and beyond, I can distribute that ugly mess right there, but it's not going to do me any good. It's not going to get me anywhere. It's not going to allow things to cross out, or no trig identity is going to pop out all of a sudden and help me out. I'm going to leave it like that. So that's what y prime is. Definitely not pretty, but that's it. Find the derivative of y equals ln of x cubed. Well, the derivative of ln of x is 1 over x. But this is an ln of x. This is ln of x cubed, which is going to require the chain rule. So let me throw that in parentheses. The chain rule is you take the derivative of the outside. So the derivative of ln of stuff is 1 over stuff. Keep the inside. So inside the parentheses is going to be x to the third, but multiply the whole thing by the derivative of the inside. The derivative of the inside has me dropping that 3 down and turning that x cubed into x squared. Now this simplifies, right? That can be moved to the denominator or the numerator, which is what I meant to say, over x to the third. And since x squared over x to the third simplifies, that leaves me with 3 over x. So in the end, and let me rewrite it out, Lincoln Park, in the end I have 3 over x. That is the derivative of ln of x cubed. Find the derivative of y equals e to the 2x cubed. Now the derivative of e to the x is e to the x, but this isn't e to the x. This is e to the 2x cubed. So this is going to require a chain rule. So I have an outside and I have an inside. It would be nice if I used the pen function. This is the inside. Okay, the derivative of chain rule, or in this case here, means you take the derivative of the outside. So y prime is going to involve me taking the derivative of e, which is still e, keep the inside, so times 2x cubed, but multiply the whole thing by the derivative of the inside stuff. The derivative of the inside stuff is 2 times 3, which is 6, 6x squared, because that 3 becomes a 2. Let me reorganize this to make it look prettier. Let me move this out front, and I am left with 6x squared e to the 2x cubed, and that is my derivative. Find the derivative of y equals cosine of ln of 4x cubed. So that's cosine of ln of 4x cubed. Well, this is definitely going to involve chain rule, but it looks like it's going to be chain rule within chain rule. So lots of chains. No big deal. We start out with cosine of stuff. Okay, when you're taking the chain rule, you take the derivative of the outside, right? So the derivative of cosine is negative sine. Keep the inside, so ln of 4x cubed, and then multiply the whole thing by the derivative of the inside stuff. Now, the derivative of this inside stuff has me doing chain rule again. So multiply the whole thing by the derivative of the inside stuff. This is ln. The derivative of ln is 1 over stuff. So the derivative of this guy, chain rule again, is the derivative of the outside, 1 over stuff. Keep that stuff, 4x cubed, but then multiply everything by the derivative of the inside stuff. The derivative of 4x cubed is 12x squared. So not much changes over here. It's just not pretty. Negative sine of ln of 4x cubed. That's a cubed. This guy over here becomes 12x squared over 4x to the third, which simplifies to 12 over 4 is 3. x squared over x cubed is x. So I could put this all together as, get rid of that and make it that. That looks better. So let me put that together as 3 coming out in front of sine. So negative sine ln of 4x cubed, close it, all over x. Gross. Gross, gross, gross. Find the derivative of y equals e to the stuff squared. So I know what the derivative of e to the x is. It's e to the x. But this looks like chain rule, and it might even be chain rule twice. Now, what I could do is if I wanted to FOIL this out, I could, and it wouldn't be so bad. But now I'm just going to stick with the chain rule twice idea because I just want to. You can't make me. So this is the inside stuff. E is on the outside. Chain rule says take the derivative of the outside, which is e. Keep the inside, which is 4x to the third plus 5 squared, but multiply everything by the derivative of the inside stuff. So this is the inside stuff. All of that I have to take the derivative of. So I'm multiplying e to the blah, blah, blah by the derivative of this, which also requires chain rule. So now I'm doing chain rule for this whole guy right here. So this says take the derivative of the outside stuff, which has me dropping down a 2, turning that 2 into 1, keep the inside stuff, so 4x cubed plus 5, but then multiply the whole thing by the derivative of the inside stuff. The derivative of the inside stuff is 4x to the third, which means let's multiply 3 and 4, make it 12. Drop that x to the third down to an x squared, plus 5 goes away because it's a constant. So to clean this all up, I have e to the 4x cubed plus 5, all of which is squared. I'm going to take that 12x squared, multiply it to 2 here, make it 24x squared times 4x cubed plus 5, close it, bracket it, although those brackets aren't necessary. And that's my answer. So you're not looking at anything pretty. I mean, if you really want to, you could distribute that and then distribute the e, but nothing's going to simplify. Nothing's going to go away. I'm going to leave it like that. And yeah, that's my answer. Given h of x equals f of x minus g of x, find h prime of 2. All right, well, this is just flat out saying if I take the derivative of h and the derivative is some function minus another function, it's going to be the derivative of a function minus another function. This is basic rules. Now, h prime of 2 is going to be f prime of 2 minus g prime of 2. F prime of 2, is a half. Minus g prime of 2 is 1. And so h prime of 2 is a half minus 1, which is negative a half. Oh, that was neat. I liked it. I liked it a lot. Ah, yes, implicit differentiation. So when you take the derivative using implicit differentiation, what you do is, since it's dy dx, you're taking the derivative with respect to x. Okay, so anytime you take anything that has an x attached to it, you just take the derivative. Anytime you take the derivative with something that's not an x attached to it, you take the derivative but attach dy dx to it. Okay? So find dy dx using implicit differentiation. I'm going to take the ddx of both sides, so 3x squared plus 3y squared equals the ddx of 2. The derivative of 3x squared with respect to x is going to be regular 6x, the regular old derivative just like we're used to. However, the derivative of 3y squared is similar 6y, but since we're taking the derivative of y with respect to x, we attach dy dx. That's going to equal the derivative of a constant, which is 2. 0. I meant to say 0. Let the record reflect. I meant to say 0. Now what I have to do is I have to get dy dx all by itself. Well, dy dx isn't all by itself. I have 6y attached and 6x floating. So let's subtract 6x from both sides. That gives me 6y dy dx equals negative 6x. dy dx still isn't all by itself. I have to divide both sides by 6y, do the same thing here, divide both sides by 6y, cross u out, and I'll put over here my final answer, that dy dx, which is all by itself, equals negative 6 over 6, which cancels out, x over y, which is x over y. And that's my answer. Find dy dx using implicit differentiation. All right, 3x squared plus 3 equals, ln of 5xy squared. Well, whenever you use implicit differentiation, you're basically going to rewrite what you were originally given. 3x squared plus 3 equals ln of 5xy squared in parentheses. You're going to rewrite it, and you're going to take the derivative with respect to x of both sides. Now, in an easy sense on the left side, what that means is if you have, an x value and you take the derivative of it, you just take the derivative as normal. Bring that 2 down, multiply it there. You get 2 times 3, which is 6. That 2 becomes a 1, so x to the first, and the 3 becomes 0. Easy peasy. Well, not so much here. This is asking me to take the derivative of ln of stuff. Now, ln of x, the derivative of that would be 1 over x. But ln of something that's not x requires the chain rule. So what I'm going to do is I'm going to take the derivative of ln, the derivative of the outside, which is 1 over. Keep the stuff on the inside. So keep 5xy squared, but multiply everything by the derivative of the inside with respect to x. So let me move that over here. That's supposed to be a straight line. Didn't turn out that way. So what I have is I have 5xy squared. I'm taking the derivative of the inside with respect to x. Now what I'll do is I will use product rule. I will call you u. It's not supposed to sound like UU, but it's too late. And I will call U V. Okay. So I need to find out product rule, which is U prime V plus V prime U. So U prime is the derivative of 5x with respect to U. I'm sorry, with respect to x, which is just 5. Not bad. However, over here, I have to take the derivative of y squared. So v prime is the derivative of y squared, 2y, with respect to x, which means I attach dy dx. dy dx. So product rule, putting it all together, is going to be u prime v. So I could actually write that over here. U prime v, so 5 times y squared plus v prime u. So I'll actually write this out as 5x times 2y dy dx. V prime. You're just making sure I got everything, and I did. Let me clean this up a little bit because I have a feeling some simplifying is going to happen, and I'll probably have to get rid of all that stuff over there too. So 6x equals, this actually just goes on the top, the numerator. So 5y squared plus 10xy dy dx. dy, I keep doing that, dx, all over 5x y squared. Now what I have to do is I have to get dy dx all by itself. So what I'm going to do is I'm going to multiply both sides by 5xy squared, multiply both sides by 5xy squared. That'll allow me to get rid of this guy on the bottom. So I have 60 x squared y squared. Did I say 60? 30 x squared y squared equals 5y squared plus 10xy dy dx. All right, let me remove this mess over here so I can finish out the problem. I'm going to subtract 5y squared from both sides. So 30 x squared y squared minus 5y squared equals 10 xy dy dx. Last but not least, divide both sides by 10 xy. Actually, not last but not least, but you know, that's fine. Divide both sides by 10 xy. You all cancel out. That leaves me with 30 x squared y squared minus 5y squared over 10xy equals dy dx. So let me flip the dy dx to the left. What I notice is all three of these terms have a y in common and a 5 in common. So let me pull out and divide out a 5 and a y. So my final answer is going to be 6x squared y minus, divide out a 5 and a y from that, so that leaves me with y, over, divide a 5 and a y from that, 2x. And there you have it. Find the second derivative using implicit differentiation. All right, well, let's take the first derivative. Take the d dx of both sides. When you do implicit differentiation and you take the derivative with respect to x, you just take the derivative normally for many of these. However, I'm writing and talking at the same time. Right off the bat, I take the derivative of a y value. What you do is you still take the derivative, multiply that 2 to the 4, bring that 2 down to a 1, so invisible 1, 8y. But since we took the derivative of a y with respect to x, we have to attach a dy dx. That's going to equal, I'm jumping the gun here. Take the derivative of 2, gone. So that's going to equal the derivative of 3x squared, drop that down, that is 6 x to the first, and now I have to get dy dx all by itself. So divide both sides by 8y, divide both sides by 8y, and dy dx is now simplified out to 3x over 4y. Okay. Now, the derivative of this guy, all right, so the second derivative is going to be me taking the derivative of this guy right here with respect to x. So this is going to require quotient rule. So I'll call you u, I'll call you v, right? And so I need to find u prime, which is going to be 3. I need to find v prime, which is going to be 4 dy dx. And I need to find what v prime or v squared is, which is 16y squared. So chain rule, if you forgot, I'll write it up here, is u prime v minus v prime u all over v squared. So let's put it all together. The second derivative, so the second derivative with respect to x is going to be u prime, so 3, times v, so times 4y, minus v prime, which is 4 dy dx, times u, which was 3x, over v squared, which is 16y squared. Now I know something. Okay, let's start simplifying things, but I know something else. Okay, 3 times 4y is 12y. No big deal. Minus 12x, but dy dx, I already know what that is. Dy dx, right here, is 3x over 4y. So I'm going to turn that into 3x over 4y. And that's all going to be over 16y squared. So I have 12y minus, let me see, what will that be? 12x makes 36x squared over 4y. So that is x squared over 4, 9x squared over y minus sign, all of that over 16y squared. So I can maybe do a little bit more. I can pull out a 3, but other than that, I mean, I'm pretty much set. It's not a pretty answer, but, you know, it wasn't a pretty problem. You're not expected to get love and joy when you deal with implicit differentiation twice, product rule, or in this case, not product rule, quotient rule. This is not pretty. It was a lot of fun, though.